calculus. I am recording this, I don't know, 5:30, 6 o'clock on Tuesday evening. At this point, I only have 2 questions from section 6.7, and that is number 3 and number 7a. So I'm going to go over those. Then I'm probably going to eat my supper. And then I'm going to go over the next section. But before I do that, I want to talk just a little bit about where my brain is and where we're headed over the next little bit. We are almost done chapter 6. We have section 6.8, which you're going to do on Wednesday. I'm going to record that today. You're going to have it for tomorrow. And then Thursday, I will go over any questions and do a review. You have a day off on Friday. We'll see how it goes, but I will likely give you a study day on Monday. So I am hoping to do a test on Tuesday, which would be May 12th. So that would be a week from the day that I'm recording this. That would be 6 days from the day you're watching this, okay? So I would like to do a test on Tuesday. That gives us 2 days for you to review and study, not including Friday, your day off, and the weekend, all right? So that gives you plenty of time to be asking questions. So that we will finish that on May 12th. After that, what we have left to do is we're going to do the last part of chapter 7 and part of chapter 8. We only do parts of it. I pull out the important pieces of it. I'm thinking that will take a week and a half. So if that takes, let's say that takes that week and that week. Yeah, let's say that takes that week and that week. That still gives us 2 weeks where I have nothing, but I don't have nothing. What I'm going to be doing is I'm going to be giving you an assignment that is going to cover everything we have done in calculus. We don't have an exam, so I have to give you something that will kind of review everything you've done. So I'm going to give that to you probably when we have about 3 weeks left. I will probably give you that. You will have about 3 weeks to do it, and I'm hoping at least a week and a half, maybe 2 weeks of it. You won't have any new information. You will simply have 2 weeks to work on it, period. Okay? And that will be your work every day. We'll just be working on that. Now, it's going to be a major project, so it will be important to your marks. You want to do well on it, okay? You want to really give your best on it. I'm not making it impossibly hard or anything like that. Yes, you can use your textbook. Yes, you can ask each other questions. If you're stuck on a type of question, I will help you with that. I won't do that precise question, but I will help you with how do I do one like that. So you have every opportunity to do well with it. But that is sort of my plan for the next few weeks, right to June 5th. Okay? So that's where we're going with all that. So right now, I'm just going to go over the answers to number 3 and number 7a on page 382. And then once I actually eat my supper, I will make a video on section 6.8, which isn't long. And then pretty much we'll be done chapter 6. You will have the opportunity to ask me any questions you want to ask me. I'll make a review video, and then you'll have time to study. And again, I'm aiming for Tuesday, so unless there's some reason why Tuesday doesn't work, I'm aiming for Tuesday. Okay, May 12th. Okay, so, whoops, sorry. Yeah, it's gone. I don't care. So section 6.7, number 3, I'm just looking at the answers just to be sure I get them right. So in number 3, it says if W is equal to G squared times H and G squared plus 4GH is equal to 2700, find the value of H that maximizes W. Okay, so we want to maximize W. We want to maximize this. So this is the one I'm going to be finding the derivative of, right? Because that's what I'm trying to maximize. So that's the one I'm going to be finding the derivative of. But again, I have too many unknowns. So in this equation, I'm going to isolate one of my letters. And I think I would isolate H. So if I isolate H, I would have 4GH equals 2700 minus G squared. And I would have H is 2700 minus G squared over 4G. Now, I might even look for Harriet. There she is. I might even 2700 divided by 4G. 2700 divided by 4 would be 675 over G minus, in this my G would cancel one of these and I would have 1/4, actually 1 over 4 times G. So I could write that as H is 675 G to the negative 1 minus 1/4 G. I would probably write it that way, okay? So the first thing I did was I rearranged this equation to isolate my H. The reason I chose H was because there was only one of them. There was more than one G, so I didn't want to isolate that one because it was going to be more complicated to do that. All right, so now that I have that, I'm going to substitute that into here. So for W, it would equal G squared times 675 G to the negative 1 minus 1/4 G. That's what that would equal. So I would actually multiply this out. So W would be 675. G squared times G to the negative 1. Well, I would add my exponents. 2 plus negative 1 would be 1. And G squared times this would be negative 1/4 G cubed, because 2 plus 1 would make 3. So when I find my derivative, that would be 675. I'd bring my 3 down, so minus 3 over 4 G squared. I'm going to make it equal to 0. 675 minus 3 over 4 G squared. I would take this and move it over here. So I would have, I'll go over here, 3 over 4 G squared is equal to 675. So I would divide both sides by 3 over 4. So 675 divided by 3 over 4 gives me 900. So I'd take the square root of this and the square root of this, and I would get that G square root of 900 is 30. So if G is 30, okay, and I know H is 675 divided by G, because G to the negative 1 would be down here. So divided by 30 minus 1/4 times 30. Okay, so I'm going to put that in my calculator. So 675 divided by 30, I really hope this works, minus 30 over 4 15. I get that h is 15 because they asked what value of h, so I'm figuring out h, and that is the answer they have at the back of the book, so woohoo. So that's how I would do that one. You might have to watch that a couple of times. The bonus is you can rewind me and play me as many times as you need to. That sounds bad. All right, number 7A. If nobody asked me 7A, I would really wonder what was going on. Okay, 7A. A country fair has a holding area for the prize sheet that are entered in a contest. The holding area is made up of 12 identical pens arranged in a 3x4 grid, and they show you that at the top of the next section in a 3x4 grid. So here's 3, and here's 3x4 grid. It says if you have 100 meters of fencing available, so you have 100 meters of fencing available. So to build this thing, you have 100 meters of fencing to do it. That's perimeter, that's not area, because you're only putting fencing on the edges of all that. Okay, so what dimensions of each pen will maximize the total holding area? All right, so that's sort of a trick question in a way. So in terms of perimeter, I'm going to come up with a formula for perimeter, okay? Now I'm going to call these W's. So I have a W here, a W here, a W here, a W here, and a W here. And I'm going to call the ones going across length. So I have a length and a length and a length and a length, okay? So the perimeter then is 1, 2, 3, 4 L's plus 5 W's. 1, 2, 3, 4, 5. Okay. Now I have 100 meters to do that. So 100 is equal to 4L plus 5W. Now, the area of the whole pen itself, the area of the whole great big thing, okay, not each individual one, but the area of the very large outside of it, area is length times width. Now it said I want to maximize the area. So if this is what I want to maximize, then this is what I'm going to be doing the derivative of. But again, I got too many unknowns. So I need to isolate one of my variables. Doesn't matter which one. So let's say I do 100 minus 4L is equal to 5W. So W is 100 minus 4L all over 5. Okay? So my area then is length times W, which is 100 minus 4L over 5. So if I multiply this out, then my area is 100L over 5 minus 4L squared over 5, right? Because both of these pieces, I just separated it out into two pieces, 100 over 5 and 4L over 5. Now 100 over 5 reduces, right? So my area would be 20L minus 4 over 5L squared. Okay, so now I want to find the derivative, which would be 20, bring the 2 down, minus 8 over 5L. I'm going to make it equal to 0. So I'm going to have 8 over 5L equals 20. And so L is 20 divided by 8 over 5. Which is 12 and a half. So the length is 12.5. If the length is 12.5, then my width is 100 minus 4 times 12.5 divided by 5. So my width is 100 minus 4 times 12.5 divided by 5, whoops, which is 10. So my width is 10. But my guess is that is not the answer that they have in the back of the book, and it's not. And the reason why it's not is because for 7A, they ask what will be, hold on, I lost it, but they ask what will be the dimensions of each individual little pen. Well, if the total length is 12.5 and it's divided up into 1, 2, 3, 4 sections, then I'm going to divide 12.5 by 4. 12.5 divided by 4 is 3.125. So I get that the length should be 3.125, and the width, there are 1, 2, 3, 4, 5 of them. So I'm going to divide this by 5, which would give me 2. And they tell me 7A, oh, they have different. They have 25 over 8 and 10 over 3. 10 divided by 3 is 3.333, and 25 divided by 8 is 3.125. So I have this one right. It's this one that they're arguing with me, and they're saying it's not 2. They're saying it's 3.333. So I'm not sure. Just a second. There is 1, 2, 3, 4, 5. So I should divide by 5, but I got that was 10. Maybe I did my math wrong. I could have done my math wrong. 100 minus 4 times 12.5 divide by 5. I get 10. All right, they might be wrong at the back of the book, but I get 2 there. I will look at that again and see if I can figure out why they say something different. But that's what I would do, okay? So, if I want to maximize my area, that's what I would do. All right. Yeah, so that's the homework, at least so far as what people asked me. Again, not very many people had finished it yet. So if there's more questions, I can certainly go over those, but for now, I'm also going to make a video in just what for you will be a minute, and I'm going to go over the next section. All right?